Hey, one sec, guys. I just realized I just realized that my CS2B meeting just got started apparently. So it's a misschedule. Let me cancel that. Give me one sec. All right. Let's see. Let's do a great. Let's see how many of us are here. Can I switch on my? Oh, my camera is not switched on. Hang on. Okay, that's better. Adjust the brightness. Okay, it's better. All right. Gallery view. Where do I go to gallery view? Oh, there's people in the waiting room. All right, great, great. Well, you know what? We're going to give other people a chance to join because the participant list is shuffling right in front of my eyes. How come it's not showing? Oh, it's just reordering. It's not increasing the number of people. Yeah, the number of participants is still 9, but the order of people is changing on the right somehow. I don't know if that's what you guys are seeing, but anyway, you know, I mean, while we wait, it's only 8:02. So let's not start formally until say 8:10 or so. All right, so we can just chit chat. Until then, you can chit chat amongst yourself too. If you just want me to switch off my camera or turn away, that's fine. You guys should just keep the airwaves occupied. That's the thing that I always make very clear to all of my students, is that they don't know that if the airwaves are not occupied, students may just join and say, well, nothing's happening, I'll come back later, and they go away, right? And then everybody does that and nobody joins. And so it's a kind of regenerative effect. So just, you have to keep talking, say something, talk about the stuff that happened yesterday, maybe talk about anything, but someone who joins needs to know that people are here and doing something. Okay, all right, so we'll start at 8:10, around 8:10. But if you have any questions for me in the meanwhile, feel free to ask. By the way, you guys should all have your cameras on, okay? Because that's the way I can also tell that, sometimes when I'm explaining a concept, I can just look at you and know that, yeah, well, that person does not understand it, but they're not willing to ask a question, right? For whatever reason, maybe they, so it's not that you're not, so many times people don't ask questions, not because, they want to, there's many reasons, right? Sometimes the bad reason for not asking question, I think, is what Mark Twain, is it Mark Twain? I don't know, someone who shared in the States anyway. So so that, yeah, yeah, I think it was Mark Twain. He said that it's better to stay silent and be thought a fool than to open your mouth and remove all doubt, right? And that's really bad, okay? Bad for students. And I don't think that is correct at all, because it's okay if you're thought a fool. Who gives a fuck about that, right? Because what we are interested in is knowing, is there stuff that is useful to me in life? Is there interesting information that could enrich my life in any way? Is there a skill that I can learn that I can use to make really cool things that are bound to improve the quality of life, of my own life, of other people's lives around me, right? So because that's really the reason why people want to learn, okay? You don't want to learn, so otherwise, if we say we don't want to be thought a fool, we just want to be sitting at home, right? We don't even want to attend college or go to school. So the fact that we want to learn, or come to school or go to college, means that we want to learn, and it's an open admission of the fact that I don't know, so I want to ask. And so that is a great sign. Okay, that's a great sign of learners. Okay, so I find in my classes anyway, people who aren't afraid to own up to a mistake, right? So maybe meaning that it could be right. If there's a question out there, they'll try to take a stab at an answer or an explanation. Even it may not be right, but it somehow makes sense, because that person would not have come up with that explanation or a hypothesis if it didn't make sense, right? So it's actually interesting to find out why it makes sense anyway, right? And say, well, okay, it's interesting that it makes sense in that particular perspective, but the correct answer is this, and the reason for that is this, right? So there is a nugget of learning there for everybody there, right? So I think that's what we're shooting for. So you should just feel free to keep talking and asking questions and pointing out issues that are incorrect in what I say, right? Or what your classmates say, because at the end of the day, and I think I make it very clear in the syllabus too, and in one of the questions in the syllabus quiz, is that I will give you lots of incorrect information, okay? So wrong things, I will say a lot of wrong things, but they're not going to be dangerously wrong things. But I will say a lot of wrong things. However, those are wrong things that you will quickly find out are wrong. Okay, it's not like you're gonna the wrong things that you go away and take your. So you'll find out they're wrong, but you'll know that I told you the wrong thing. And the reason for that is not to mislead you. Okay, because I totally firmly believe that the job of an educator, or at least my job anyway, is not to give you facts. Okay, I don't believe that my job is to tell you this is right and that is wrong and do this and don't do that. Okay, that is total bullshit. Okay, anybody can tell you that. So what I would like is for you to become able colleagues to me, right? So thinkers that you can have a great conversation with. Okay, and dive into interesting problems and look at things from new perspectives. Okay, and from that perspective, it is not useful to give you lots and lots of facts and information, because information is so cheap these days, right? So all you need is just a Google query, or you go to Bing or some place and just type in something and you get loads and loads of information, right? So giving information is not the right thing, because if I tell you something is right, what is the difference between some website telling you that is right and me telling you that's right? If you just trust me blindly, then you're bound to be a failure in life, right? Because you never trust someone blindly. You got to apply a good sense to it and say, does it make sense? Is it right? Okay, is this right in light of what I want to do in my life? Okay, and those are the kinds of questions we ask, right? So if we keep asking these questions, I don't know how we got started talking about that, but essentially, I think the bottom line is that you just feel free to ask questions. And I don't know how we got started talking about that. I was just trying to keep your airwaves occupied. It's about 5 minutes since I started talking, because I started talking at 8:03. Okay, so but that's basically it, right? So you should just feel free totally to so basically the point, I'm giving you the wrong information sometimes as opposed to the right information, is for you in machine learning, for example. Some of you may be already doing maybe machine learning people in with Python and things like that, but essentially this is the core of a machine learning algorithm, is to supply the algorithm positive and negative examples. Okay, so you don't tell because if you don't have a machine learning system, right, a system that can learn whether something is correct and something is wrong, that is a machine learning system. All right, there's another kind of AI system that we used to play around with, right? When I was a student, this was all the rage too, right? And now it does have a home, right? This paradigm of artificial intelligence does actually have a home. And it is part of every machine learning system now. In fact, inside of Alexa, inside of Google, right? So that component still, it is a rule-based AI system, meaning that there is a whole lot of rules, okay? And the outputs are deterministic. So if you supply a certain bunch of inputs, the output is, you can predict what the output is going to be. This is deterministic output. So that is a rule-based system, and rule-based systems are very, popular in AI. And but in rule-based system, we have human knowledge injected into the AI. So it's really not AI, it's actually human intelligence, right? Because a rule-based system is not AI. It is masquerading as AI in the sense that it's a computer, right? It's going to answer all your questions as though it's a human, but really it's not AI, it is human intelligence, which is encoded inside of the computer. right? It's sitting there in the form of rules, right? So Brian or Ali or someone actually went there and painstakingly created all these rules encoded in C++, and they're living inside of that computer. So even though these people are out there enjoying life somewhere else, what their knowledge is now embodied in this program, and that is going to make decisions for you. Is that AI? Right? It's not AI, yes? It's really, right? But a lot of, many programs are in fact operating like that. And we just assume that it's AI, right? So there's the line is kind of loose when it comes to the user's perspective. They can't tell the difference, right, between machine learning and AI, which also encompasses rule-based systems, right, which are purely deterministic. But you know, rule-based systems, if I train you into a rule-based, so where I was going with that is that if I train you into a rule-based system, which is obedient followers, okay? If you have a system of governance in which you have to have, everybody's got to be an obedient follower, okay? So only the king or the despot decides what is right and what is wrong, okay? And who to believe, what is right and what is true, who is God, okay? Only one person can decide that, okay? So, and if that is the perspective, that is a rule-based system. Yes, it's a rule-based system. And in that case, individual entities don't have any intelligence. And you're not expected to be intelligent entities. In fact, they could all just be robots. This is one grand guy here, okay, the head of the institution, and he or she calls the shots, okay, and says this is what every person has to do in their life, okay, and that is the person who's the only intelligent entity in that universe, okay, because everybody else, for the good of the universe, needs just to be autonomous robots who just blindly follow that person. So that's a rule-based system. So in that case, the intelligence cannot be said to be embodied anywhere else other than that one person. Okay, so however, that's not the way modern machine learning systems work, because machine learning systems, as we all know now, they're very flexible, right? So you can make a bunch of mistakes, but if if you're talking to Alexa and you continue making a certain bunch of mistakes, I'm actually surprised that Alexa didn't pick up, even though I mentioned the name a couple of times, because a couple of quarters ago there was actually a student called Alexa, Alexandria in class, and every time not every time, the first few times I said Alexa, she would basically pick up and say, hey, what's the answer? Well, now it actually picked up because I heard the bit. But anyway, that's interesting. So in a machine learning system, we actually treat the system as intelligent, meaning that it is able to learn. Yes, okay, not as dumb people who can just be told rules to follow. So I don't expect you to be dumb people expecting to be given rules to follow, because that's no fun for me, and I'm sure it's no fun for you, because you've been very obedient in many different places, and here's a place where you don't have to be obedient. You can actually be your own true self, curious, inquisitive, asking questions, trying this and that and everything, right? Because and also cross-examining me. Right? When I say something that is wrong, that doesn't make sense, saying, hey, that doesn't make sense. Okay. So, and again, I think I had this observation I think 3 lectures ago in a previous quarter, right? 3 lectures meaning, rolling over to the previous quarter. So a lot of people are hesitant to correct professors, right? Oh my gosh, waiting room, 3 people. You know what? I should change the settings for this meeting to automatically admit students, right? Because yeah, that's what I had it like before. I had it like that before, and I didn't keep checking the waiting room, and then there's people in the waiting room that need to come in. I'm really sorry, guys. So you were in the waiting room and I didn't realize, but basically, let me close this participant list. Close, yeah, close that. Okay, that's good. All right, but basically well, I hope the participant, it's not, this meeting is being recorded, I hope. I hope it's being recorded anyway. I kind of promised all the students that we'll have a recording of all these meetings. But anyway, so, well, if this is not being recorded, I hope one of you got it. I don't know. We'll see, we'll figure out something. Anyway, where I was going with that was that, yeah. So my fun for you and fun for me is just to be, as a student in the past. So yeah, no fun to they feel uncomfortable correcting professors, right? So if a professor says something obviously wrong in class, students don't feel comfortable saying, hey, it's not right, right? Yeah, because I know because I've been in that situation in the past. But one way you can get around that is just to say that what you said doesn't make sense. Yeah, because there's only one sense, and that sense tells you whether things are sensible or not, and you can't say that it's sensible to me and not sensible to me. So both of us have to agree. So if it doesn't make sense for you, either it doesn't make sense for me too, right? In which case I'm wrong. You can basically use that as talking to any professor, not just to me, right? You can just say it doesn't make sense to me. It doesn't make sense, and that is could be a synonym, a euphemistic synonym, right? So a nice way of saying to a professor, saying, "Hey, you're wrong." Right, and every prof basically loves students who does that. Yeah, I say that in a good way, right? So they want students to because ultimately at the end of the day, professors have the luxury of running their ideas past many students, right? So if you go to a deep physics class, right, and the physics professor might have an intuition about something, right, and before they formalize or put some energy into the intuition, formalize that into a big theory, they might want to run it past a lot of people, a lot of intelligent people in class, and see if they can poke holes in it, right? Because that's the best way to do it. Yes, think about it. I don't know, you guys haven't been in the field doing research, but when you do research in the field and you have some incredibly interesting result to share, right? And you can share it with all the people in the lab and your limited network, but you really want to know if this experiment can be repeated in a completely different setting, in a different country, different elsewhere, and so on. So you want to publish it, you want to send it to a journal, and then it'll take several months before, especially IEEE journals, they're not notorious. Oh, they used to be notorious anyway, right? Back in the day. And it takes a long time. But these days, I don't know, maybe it's different, right? You publish it on the internet and things travel fast, but still, it's not like instantaneous, like in a class. And so that's what professors are also looking for, is that sometimes they may have theories that they want to run past students, and seeing it is being recorded. Thank you, Keenan. Okay. By the way, you know what? You guys are you guys muted? Why are you all muted? I think you shouldn't be muted. Okay. You should all be able to. Oh, I see, you're muted because of the feedback effect. Yeah, I think that's probably one of the things that we had an issue we had before. No, I don't think we had a feedback effect. Okay, can you guys unmute for a sec? We'll see if you are. All right, no feedback, right? No feedback so far. Prapul, Zain.
No feedback so far.
Okay, yeah. Hey, Prapul, are you muted? Hey, Zain, Prapul, and Yuha, your cameras are not switched on, okay? Cameras are switched on, and Jennifer too. Jennifer and hey, Sam. Yeah. I couldn't tell if that's a photo, especially with your scenic background like that. That's really cool. It's really cool. All right, thank you guys. Anyway, you know what? We could just go on and keep talking, or this class, really, I'm hoping for it to be an icebreaker. We can talk, and today and on Thursday, well, this entire week, really, right? I don't expect you to program at all, right? So no need to submit any quests, because quest 1 is only due at the end of the week 2. Yes. It's freezing at the end of week 2, so don't code any C++ this week if you can help, right? If you can help it, code, do the data representation thing, and for getting participation points, here's a cool way to do this, right? Convert your name to in module 0. This week is for module 0 and data representation, and believe me when I say this, please, right? Because then a lot of students have found out the hard way is that data representation will make your life, mastering data representation will make your life as a C++ programmer an order of magnitude easier. Okay, you can still be a successful programmer, C++ programmer, right? But if you're going to put a lot of effort into something, there's only a certain level you can reach, right? Because everybody is limited in the amount of effort they can put in. So in order for you to reach higher states in C++, you need to take all of these easy things and just master them, because all the skills that will make you better and easier for you downstream, just pick them up right now, because it's so easy, right? So data representation, don't underestimate it. Okay, a lot of students just say, well, I don't need data representation, I can still get a CS2A passed. Yeah, sure, you can pass CS2A without mastering data representation. but but there will be a ceiling. So that's like a glass ceiling. You won't see it, right? That's the problem. You won't see it, and many times I've seen people, out in industry. They say, well, there's a glass ceiling. I can't get past that level, right? Those are managers or senior managers, and I'm doomed here. I can never get there. And but but many of them, when they reflect, right, it's not possible for them to get up there because they're missing a critical piece of knowledge that you can get to this level without that knowledge, right? But you need that knowledge to get to the next level. And just because, and that's why data representation is going to make your life a whole lot easier. Take your time, convert your name to base 27, right? Or hexadecimal. See if you can get some way of turning your name into a pronounceable hexadecimal name, right? We have not had, but we've been questing for how many, a couple of years now. Well, I don't know. The data representation module was even written a couple of years before I made the questing system, right? So that's been around for 4 years now, right? I think a couple of years after I started at Foothill, I wrote data representation. So yeah, so since then we have had only one person, I think, who has had a pronounceable hexadecimal name. Okay, so I don't know if you can somehow come up with a, you can't say, Jennifer might say, well, Jennifer does not have a pronounceable hexadecimal representation, but Jen has, or Jenny has, right? Okay, that's okay. That, those are allowable, but you can't say, well, you know what, if I use my name Jennifer, right? Jennifer, I can get a pronounceable hexadecimal name. That doesn't count, okay? So it has to be a common variation of your name. And if it's pronounceable, that is really, really cool, right? So you'll only be the second person, I think, right? But it's not just a pronounceability of your name, right? Lots of people have come up with really, really interesting things about their name, converted from one base to another. And it's all fun, right? It's fun, and it will set you up for, save you lots and lots of frustration later on. Because I can't tell you how many times, and even in CS2C, students who have been banging their heads on a wall for 3 to 4 hours. And when you bang your head on a wall in 2A, you may think it's frustrating. But if you bang your head on a 2B wall in Greenland, okay, it's not only frustrating, it is both cold and frustrating in Greenland, okay? So, it's going to be doubly frustrating because, the problems are harder. And also in 2B, you also have a feel, and you have a certain level of confidence in yourself, saying, well, I know basic C++, I know the mechanics and the control structure, so I can't be wrong there. So you're very confident of your program, and it's still not working, right? So the logic is gone somewhere, awry, and you want to go into your code and find out where it's wrong, and you can't see where it's wrong, and that is, doubly frustrating. And then imagine when you go on to, red in CS2C. Those frustrations are even harder. And I have seen, and so 3 hours of frustration in CS2A is like 9 hours, dog hours of frustration in CS2C. And I've seen people, students who got frustrated in 3 hours and 3 hours or more in CS2C. Turns out it was really because they had missed something very obvious due to data representation issues. Okay, they had infinite loops where they shouldn't. And it was because of rollover problems, which you would subconsciously learn to avoid, right? Once you master data representation, you'll know how to avoid these, rollover issues, because those are issues that cause a lot of grief downstream, right? When your logic is right, but something happens at the data representation level that you don't know, right? Imagine, already I think you can get a feel, right? Because you can look at your code and you can see the data, logic is bulletproof. There's no way that could go wrong, and yet this is not working, right? And it's because of a gap in data representation that you missed. You didn't realize that you decrement a number below 0. It doesn't go to -1, but it actually becomes infinity all of a sudden. Not infinity, a big number, right? And those kinds of things become second nature to you, right? After you master data representation, or even when you come to later on to bit manipulation, and you say, I'm going to use a large number of bits to say whether I have an element or not, right? Presence or absence test. And you want to know if bit number 755 is on or off. And you want to devise some tests to do that for all of those things, which you'll do extensively in C++. So for all those things, data representation is useful. So this week's participation points you can get by talking about data representation issues and making interesting observations about each other and helping each other with data representation issues, and do it on the Blue subreddit. Oh, there was actually someone who asked me, there's going to be a class Discord or Slack channel. Okay. And I want to warn you guys already, right? Because I think this issue has come up several times in the past. You guys are welcome to have Discord and Slack channels outside of the sub. But many times students who thought they were participating a great deal by helping other people and being very present in the Slack and Discord channels and so on and so forth, they got 0 for participation at the end. And sent me an email saying, why did I get 0? I was so helpful. I was always there on Discord for other students. Right? Yeah, I can see it, right? So you only get points for the kinds of interaction that have been described in the syllabus on the subreddit that's officially recognized by the class. So if you're in Blue subreddit, you're fine, okay? You have to be asking questions there and demonstrating that you're making progress or at least struggling and learning things, okay? And a lot of students also, I find, question anonymously maybe, or and just submit the final polished solution one time, bam, like that. And the system has no way I can instrument it using IP tracing and so on. But right now, I just don't care because so I don't have any way of distinguishing such a submission from someone who just went online. I know solution to these quests are floating around online. Okay, people can buy them because as early as at least 2 years ago or 1 year ago, people were offering to sell these, buy solutions, quest solutions off you for about $250 or $100 or something like that. So I don't know. So these solutions, there must be lots and lots of those floating around. So that's bad, too bad, right? For the student who did that, that would be too bad because they missed out an opportunity to. Because the person who came up with that solution, think about it from the perspective of the person who actually came up with that solution in the first place. They learned so much stuff in coming up with the solution, right? Because for each one of those things that you just took for granted and copied, even if you took a tip sheet and implemented every one of those things, you just did it. Yeah, it worked. I got my points, okay? And you didn't learn anything from it, right? Because that person, each of their tips took them about 2 hours to discover on their own. So I think it would be great if you could just, but also I think, incidentally, you should pass this message on to all of your classmates and friends. From next quarter onwards, this is what I'm going to do. So the quests in CS2A, right? All of the Blue quests, they are so essential to have a successful CS2B experience, okay? Not obviously first required for CS2A, but they're so essential because they take you all the way up to pointers and feeling utterly comfortable with pointers, because that's a basic. Otherwise, if you're not dealing with pointers, you may as well be programming in BASIC or some other language, right? So the pointers give you the real power of C++, dealing with bits and so on. And getting all the way to Quest 9 is what tells yourself that this is the reason I did CS2A and not 1A, for example, which I've done other times, or I want to learn Python, Java. But why do I want to learn C++? Because C++ has certain things that I can't find in other languages, right? That's the reason I want to learn this particular language, not because, I want to go to Santa Barbara, right? It is a party school, and they are all C++, okay? So, so that's why I want to learn C++. That is a total nonsense reason for learning C++, right? So you should learn C++ because you want to learn the power of C++ and say, now I know C++, what are all the schools that take C++, right? So, this xyz.edu, which is the best in the whole world, unfortunately, it doesn't take C++. Too bad for that school, right? I'm not going there, okay? So you take some of the school, and you go to a school which takes the language that you're interested in, and you will do yourself a favor as well as the school a favor. And I think that is my perspective on this thing. But what I'm planning to do is that because the Blue quests are so essential, I'm going to make this all for credit in CS2B. So if any of you or your classmates is planning to enroll in my section of CS2B in a future quarter, and you complete all of the Blue quests now, you can use all of your solutions for credit in CS2B, right? Meaning that there's going to be at least 10% of the total CS2B grade that is required to be obtained by solving all of the Blue quests in 1 week. That is the first week of class. Because in the first week of class, just like you guys are working on data representation, CS2B will get the first week to solve the entire blue quest, starting from tiger all the way to the duck, right? So all 9 quests have to be done in 1 week. Now you may think that, oh my gosh, that's going to be impossible because right now it takes me such a long time to get past each quest. But you'll be totally surprised that after you finish the 9th quest, if someone asks you how long will it take you to complete all of the 9 quests, you'll say it'll probably take me a day or a couple of days, right? That is not even if you even if that person said you have to start with a blank slate. You can look at your past solutions. You can look at the subreddit. You can copy code. Right? You got a blank slate and a C++ compiler in front of you. Even then, they'll say I can do all of them. 1 to 9 in less than a couple of days. You'll be surprised. And I think that having that ability should count for something. And right now, it's not counting for anything other than implicitly encouraging students. So next quarter, or when you guys go on to 2B, you'll find that you can get at least 10%. For all of the blue quests, okay? So there you go. So I think it would make double sense for you to just complete all of the quests. And also, my request and recommendation is that don't buy solutions, don't share solutions on Discord and Slack and all these outside forums, okay? Keep all of your discussions only on our subreddit. It's okay to ask questions, okay? If the question is a dumb question, don't worry, okay? I'll delete it. I'm not going to dock points for all dumb questions, okay? You can ask dumb questions. And so I only dock points for mean questions that get deleted, right? So if someone said something and you said, that's a really dumb question, get the hell out of here, okay? Now, that dumb question gets deleted anyway, and your comment also gets deleted, but that person doesn't, suffer any consequences, but you'll have a -1 or something like that because you were mean. And so it's okay to ask dumb questions. It's fine, right? Either me or hopefully one of you guys, because you're all looking out for each other. I hope, right? I don't want this to be a competitive class in which each one of you is trying to get up to the top by climbing on the others. That's a totally nonsense kind of class, right? I'd hate those kinds of classes, to be in a class as a student or to teach that class. Okay, so I just want us to all to have a party here, meaning a C++ party. Okay, so we're all helping each other to have fun in C++. Okay, so if there's something that someone doesn't know, you should help them. You just check it out, right? You can get a breakout room, right? Go to the STEM Center, you can get a breakout room anytime, right? So you have a Zoom, the whiteboard, shared whiteboard, everything is available, right? But if you're on campus, you can just go directly to the STEM Center, right? They have generous hours now, so all those things are available. You should, help each other out and have fun in CS2A. I think it'll go a long way, and hopefully, the number of students that I have who continue on to do 2B and 2C with me will. Right now, I think I have a very small number, a small fraction of students who manage to complete all of the 27 quests, meaning all blue, all green, and all red. But in their respective quarters, right? Because I have some 2C students who said, I want to do 2C. Can I have an ad code? And I say, well, you can get an ad code only if you solve all the blue and green. And they go and solve all the blue and green, okay? And they get an ad code. So even those guys have done blue, green, and red. I'm not counting those guys, okay? So I'm talking about students of mine who did my 2A and then did my 2B and did all the green quests. And so there's only been a handful of students like that. But it is actually growing because a number of my 2A students are in 2B also, I think. I hope they're not in the waiting room somewhere. Okay, I got to change the participants. Hang on just a sec. I don't think there's anybody in the waiting room. Where's the thing gone? I don't think there's anyone in the waiting room. Well, if any of you, there it does say, okay, all right. Admit all. Okay, all right. So I'm new to this kind of thing. Okay, I didn't used to have a waiting room before. I'm sorry, guys. I'm really sorry. Okay, I'm going to change the settings on the meeting to make sure that everybody is admitted into the meeting immediately. There's no waiting room nonsense. Is that okay? I don't think we covered anything useful, but I still would highly recommend that you watch the video. I hope it's recorded. Yeah, it is recorded. Someone said Keenan said it was being recorded, so confirmed it was being recorded. So I would highly recommend that you watch the video, and because no point repeating all that stuff. In fact, all of that stuff has been said many times before in previous lectures. You can just watch all the previous recordings, and they're all there. And in fact, what you should do is before you come to class, just watch at least portions of the corresponding week from previous quarters. I think it'll be fun, right? Because you'll get to see. By the way, guys who are just joined, all of you need to have your camera on, okay? All of you need to have your camera on. If you don't have your camera on, you should need to have special permission from me, okay? Yeah. All right, and Prabhu, I don't think you're present. Are you present in class, Prabhu? Because I spoke to you once before, you didn't respond.
Yes, sir, I'm there. Yes, Professor.
Okay, you need to have your camera on, okay?
Oh, okay, Professor.
Okay, all right. And all of you, Michael, Min. Hey, there's 2 Min. Oh, Min, you've got two logins? Hey, you're logged in 2 times. I think it's interfering with the audio. Can you cut out one of them maybe? Hey, Michael, your camera is not on. You have Sean. Michael, is it? You got 2 Michaels? Are they the same? Hey, Michael, you have 2 windows? Michael, are you there? Okay, so some of you guys are stepped out. Maybe you got to get back to me. All right, we'll come back to these guys later. Last time, is everybody okay so far? You know what? It's people are entering the waiting room. Maybe I need to change it right now, or someone's got to. Can you guys see the waiting room, or only I can see it because I'm the host?
Only you can, I think.
Yeah. All right, I got to keep an eye on this.
Can I rejoin on my computer?
Hey, Michael, welcome. Yeah.
Hi, sorry, I had to switch computers.
Oh, you were the one who just spoke? Rejoin on your computer? Michael?
I was on my desktop, but I don't have a microphone or a camera attached.
Oh, I see.
Yeah.
Who's the other Michael? Is that you?
The other Michael? Oh, yes, sorry, that's me.
No. There's another Michael McDonald, but there's another just Michael. Plain Michael.
There we go. How's that?
No, there's a Michael under you too.
No, that's not me.
Oh, that's not you. Okay. All
Well,
right.
maybe it's me. I don't know. I tried to join in several ways.
Don't never mind. Okay. So that's good. All right, thank you. Yeah, Brittany, that's fine. You can keep your you can step out from time to time. You can switch it off from time to time. That's fine. I just need to know that you guys are here and attending class and somehow actively engaged, right? And I actually do remember all of these things. Okay, the participation points and so on. I just remember. In fact, even from a couple of quarters ago, people can ask me, how much did I participate? I think I remember this until it's very long ago. Waiting room still. I'm just going to leave it open. What time is it now? Do we have? Right, 8:38. Great. I think I've pretty much monopolized the airwaves all the time. Didn't let you guys talk. Right now, what I'd like to do is, you guys can take over, right? You can talk amongst yourself, or you can ask me questions. It's basically going to be about data representation this week, this entire week. Like I said before, do not code, right? Forget about C++. We got a lot of chance for deep C++ later on. We'll do C++ in week 2. Starting week 2, we're just going to be immersed in coding all the time. So this week, take a break from it, and it's just data representation. And it's going to be pencil and paper, okay, or iPad and whatever. So you got to and on the forums, share your 26 base 27 or base 20. I forget, it's a long time. Base 27 name. Spark up some conversations about other people's interesting names. Convert other people's names, or maybe even find the. One time we had an interesting thing. So let's say Kai and Sam. Okay, 2 short names, right? So Kai and Sam. So they say, what is the Kai plus Sam? And you can actually do that in base 27, right? It's just like 543 plus 222, right? So it's 2 numbers added together, and so you have SAM plus KAI, and you can find the sum in base 27, and you can say, this is what it comes out to, and it's all really interesting conversations. We've actually had that. We had, I think, 1 year ago in a quarter, I think 2 students. I think it's Andrew and someone else. I forget the other person's name. They had an interesting conversation on Reddit. where they said, what is the product of these two people, right? What is the product of these two people? And they did it in base 27. And they calculated the product of two people and said, this is what we produce. And it's kind of cool. So you can do all these cool, really nice, interesting discussions in the forums, okay? And try to, and again, for the benefit of everybody, just just stay on the Reddit, okay? Don't go into the forums that don't get points or invisible to everybody else. All right, so there you go. You guys can ask me data representation questions, or if you have issues in the data representation quiz. By the way, syllabus quiz, I hope all of you complete it. It is actually designed in a way in which you will get at least a few wrong answers, okay? Because if you get everything right the first time, I don't know, the syllabus quiz, I got to go back and redesign it. The goal with the syllabus quiz was that to make you wrong in a few places with the intent that will give you a motivation to say, oh, wow, why is it wrong? Let me look at the syllabus, because you got unlimited tries. Yes, with the syllabus quiz, you got unlimited tries. So you can go back to the syllabus and say, well, I got this wrong. Can I look at the syllabus? And you look at it a couple of times, then you actually understand it very clearly. Because what I've found in the past is that many students just, I want to do CS2A, just look up 3 classes. Okay, well, check mark and sign and get in. They have no idea what the class requires of them. And I found that there was at least 50 to 60% of students entered class like that. They had no idea what was required in the syllabus, right? And I found that this was a good way in which we can make sure that every student actually understands what the syllabus, lays out. And so this way you can actually see, unless you got all the questions right, there's something in the syllabus. Some things in the syllabus that are interesting or useful or important that you missed, right? So you can, and I tried to make the syllabus as easy to read as possible, okay? Not very, full of jargon and complex. So it should be simple and easy. So if you have any questions about the syllabus, yeah, what better place to ask it, right? Either class or in the forums, perfectly fine. And so you can ask syllabus questions, you can ask class questions now, right? Because today and Thursday, we're not coding, right? It's just informal discussions and data representation issues, right? And also you can ask about specific issues with data representation that are confusing, right? Because we have today and Thursday, right? And you can talk about two's complement, floating point representation, how to understand two's complement. What is, different ways of what are the benefits of two's complement? The things that are hard, basically things that are hard in data representation, right? What is the difference between signed and unsigned? Okay, signed and unsigned, those are important also, right? So those are things that you can talk about and ask me, or even, help each other out, and that's even funner, okay? So if, for example, if Dwayne has a question and then Zane has an answer, okay, it'd be fun. It'd be fun for all of us to watch or participate or help each other or, chime in. So those are all really cool discussions to have. And remember that you should use these videos, these recordings on YouTube, right? All of these classes to your benefit, really, because because they're going to be public, right? So ask. This is going to be a chance. You can prepare for these things like you are preparing for a talk show, right? So you think that who is this famous talk show host? This is guy with lots of cars, Jay Leno, right? So I don't think he just comes and talks off the cuff, during his right. Many hours of preparation have gone into that apparently spontaneous thing on stage. When he's just talking off the cuff, but no, he's thought about all those things before. And the reason is that he knows that a lot of people have paid a lot of money to watch those 20 minutes or 2 hours, and if they've paid money, then he's got to make it worth their while, which means he just can't come and talk off the cuff. So he's got to say, well, you know what, that money is basically like 15 hours of my time, but they don't have 15 hours. So I'm going to think about the 15 hours and condense it down to 20 minutes. So take all the best bits out of my 15 hours of thinking, condense it to 20 minutes. That is worth the money that people are paying for their cable subscription, right? So that kind of thing, that's the kind of thing that Jay or all these people, really talk show hosts, Oprah, right? So they put a lot of work before, and you can consider this as an opportunity for you. And you can say, well, you know what, every Tuesday and Thursday for the next 11 weeks or 10 weeks, I have an opportunity to have a recording out there. It could potentially go viral because of something I said, right? So is there something I could say that could go viral? Or is there something I say that I could, bookmark and share with my friends so that they can look at that and then share with others? right? And hopefully it may, if I don't know, you may already be a professional just doing this for fun. But if you are, for example, hoping to be employed by a particular company, or you want an admissions officer to look at it, right, and reach them, that would beat hands down any recommendation letter that you can get from anyone anywhere in the world, right? Even if Joe Biden writes you a recommendation letter, I bet that would carry less weight. Well, obviously carry a lot of weight, right? But I think it'll carry less weight in an admissions officer's eyes than if they saw a really, really insightful post by you, right? You making a point that you are passionately convinced about on YouTube and trying to convince another student, right? Because those are the kinds of things that other people want to pay for, right? Because other things you can always get. But most of the things today I can get with robots, right? Or software, right? These days I don't even have to walk to my supermarket, right? Grocery store. I can just talk to Alexa and she'll get everything delivered to me, right? Like that, to my doorstep. So many things that you don't have to do these days. And I don't know where I was going then, but essentially, So what people pay for is not grunt work. I think that's where I was going, right? So eventually, in the world of tomorrow, right? I think in the world of tomorrow, people won't have to work unless they really, really want to. Meaning that there's something they want to do, they'll do it. Otherwise, they'll just be happy and not bother other people, right? So, but I think that in going forward, what will be valuable is not going to be grunt work, okay? Because grunt work is just going to be automated. Everything is going to be automated, okay? So the only thing that's going to be valuable, even 5 years from now, is original creative input that is going to be really, really hard. It'll take many more years for AI to, AI is really, I'm pretty sure it will get really, really creative at some point, right? But it's going to take much longer than now. Anyway, I think that is my opinion. Again, might be wrong, okay? You can correct me. In fact, the better way to correct me is to prove me wrong, right? Go out there and do something that I say is impossible, right? And then say, hey, you know what? I want to go back to that lecture you had 5 years ago, and you said that's not right, and it's impossible. Here you go, I did it, and I sold my company for $3 trillion to somebody in Mars or Pluto, right? So you can say that and say, you can prove me wrong, and that's the best way of proving me wrong, right? So, you can also say, you're obviously wrong. Doesn't make sense. Yeah, okay, I'm obviously wrong, but but you didn't get, it's so obviously wrong. It doesn't give you a great deal of learning, right? So we only learn things when we spot things that are wrong, that are not obvious to everybody, right? If something is obviously wrong and you say that's obviously wrong, I didn't learn much from it, right? This is obviously wrong. Everybody can see it, right? The people who made lots and lots of money, who are really valuable, who are really happy with what they found, are the ones who found something that nobody else could find. So you got to find some stuff that's not obviously right, obviously wrong, and say that's wrong. Okay, lots of things I say not obviously wrong, maybe, right? Some things are obviously wrong, but you got to look for the things that are not obviously wrong and say, okay, how can I disprove that? How can I disprove that? I want to go and make sure that I can make Anand eat his words. Okay, so I'm very I will be very pleased if you can do that. Okay, so all right. So are there people in the waiting room? Yeah, there are people in the waiting room. Okay. All right. So all right. Min, hey, Min, I thought you were here already. Oh, you signed out and came back in? Oh no. Min, you're back now, right? Okay, good.
Oh yes, I was having problem with my.
Yeah, sorry, I didn't see you come back. Okay, so I could have let you.
I got it. It's good.
All right, so I'm going to collapse this participants list again. I don't know. I'll check again, or maybe Zoom will pop up more prominently that students are joined. All right. Okay. So yeah, you can talk about anything you want, like data representation issues, or have questions about the class. I'm happy to answer any other questions you may have. And save your questions about coding until next week. From next week, we'll start coding. I hope every one of you will get a chance to code, okay? I really want every one of you to get a chance to code. This coding is really, really fun on screen, okay? Because on screen, a lot of people told me later, okay? So some students, some students felt so, in the previous quarters, right? In all the recordings, some students felt so anxious and nervous and stressed when coding on screen. Okay, and I can relate to that because you're coding with all these people watching you and the professor also watching you. right? And everything you do, you got to be right. And then many of them just turn into robots at that point, where they shut off their brain and say, I'll just type exactly what the professor says. And I don't want that to happen. I want you to be yourself and make mistakes, sometimes type ahead of myself, type ahead of what I say and then correct it and so on and so forth. It's all a very useful skill to have. It's a very useful skill to have because you'll be coding together with other people very soon, lots and lots of people too. And this will also help you get productive with all of your other projects and everything very quickly. And so coding in public is a useful skill to have. And again, here, the reason I say that, when I went back and spoke to the students who said they had a really nervous and tough time coding, apparently they said that, they felt it was a great achievement for them to have successfully survived the coding session live on screen. And I said, that is that is not the stupidest thing you should feel. No, that is not the thing you should feel, right? You should not feel a great sense of achievement for having survived a coding session. But what do you get if you survive a coding session live on screen, just typing like an automaton, right? I could have a speech recognition system, right? And basically just do everything I say, and doesn't. So yeah, I think what you should feel good about is, I actually, in the process of coding, I actually learned not the entire thing, but 10% of it. That is really good, because what happens is that I found that, so I said, was it completely useless? They said, no, it wasn't completely useless, because, maybe there were 4 or 5 concepts that were introduced in that live coding session when I coded. And in 3 or 4 of those concepts, I was coding like an automaton, because I was basically just, shutting my mind off and typing whatever you said. That's perfectly fine, because, that works. I want to make sure that you all are okay with knowing that you have a parachute. You have a parachute right there. If you offer to live code in class, you have a parachute. You can never go wrong, because at the worst, you can just type exactly what I say. I'm going to speak, or your classmates, one of us is going to say, you type FOR space, curly brace. No, curly braces, all those things, every single thing we will. So you have that fallback. Nobody is ever going to be completely stuck. Okay. However, when we did that, maybe we cover like 5 or 6 different points in the process of you coding. And the interesting thing I found was that when I asked them, well, did you get absolutely nothing from that class when you were basically just blindly coding? Because, when you code, you're basically sacrificing. You're sacrificing your mind for other people's benefit. Essentially, think about it. If you do it that way, you're saying, I'm going to shut off my mind and just keep coding so that at least the other students are not, affected. They can follow the code and listen to the professor and look at the code, and they can learn. So I'm not going to learn. I'm going to sacrifice my learning for the other students. Yeah, okay, that's not a good way to do these things. And so I said, did you learn absolutely nothing that way? He said, no, actually, no. I actually did learn a couple of things. There were only 2 concepts of the 5 concepts that we covered that day. But the interesting thing was that it was not completely autonomous, even though that person was performing in autonomy, autonomous mode that day, just typing in exactly what I said. From time to time, even when they were typing, they were actually thinking about what I said, right? That time to time needs to be improved from 20% to 100%, meaning that 100% of the time as you're typing, try and bring yourself to a state of mind where you can also think about what you're typing, right? Or think a couple of steps ahead. Thinking about what you're typing, I found in my experience, not just in programming, okay? Anything, I think, even if you're playing music, right? A piano or violin or things like that, I think when I used to see my daughter playing, for example, right? If she's thinking about the notes that she's playing, she eventually goes out of step with the meter, or she stumbles and hits the wrong note, right? However, if she's already played that thing like 100 times and knows what's going to follow, and she's not thinking about what she's playing because she knows her fingers are going to play the next few notes, right? She's not even thinking. Those notes sound really beautiful because they actually blend into each other, and all those nice nuances can be expressed because you're not thinking about the notes. And I think that's what I find. And same thing with programming, right? If you're thinking about the programming, you can't appreciate the nuances of programming, right? The nuances of programming is where the science actually lives, right? Where outside of the nuances, well, it's not even the science. It's the putting things together in the hope they'll work. right? But going to the nuances is where you can actually see the science of programming, the real science. And say, well, this is the reason we do it that way, because that's why, you know, science is finding the reason for things, right? Why does the apple fall to the ground? Why? So asking the reason why and finding out why does this happen, right? So that's the reason science. And you can always say, here's a machine, it works, okay? And you can say, well, you know, if I put the switch on, it's going to work, okay? That's not science, right? Even though it's predictable. It's a scientific statement saying that, you know, the predictable is 99% true, that if I flick the switch on, that machine is going to work. And it's a scientific statement. You can predict it, right? Yeah, I can make an observation. It's a very silly experiment, but it's still a scientific statement, right? So you can say I could learn some science there, but because I have a predictable phenomenon right there. But that is not the real science, right? The real science is going into the nuances of the machine and finding out why the hell does it work, right? Why does this machine, rise to an altitude of 70, or pi meters or something like that, right? Why? In order for it to, so it's getting to the why is the heart of science. And in the same way, when we come to programs, getting these programs, other programs together, getting routines, oh, I have to use a for loop, I have to use a do loop, and put these things together, it works, okay? Yeah, okay, that's like flicking the switch and getting the machine to work. But that's not science. But the fact that you enrolled in CS2A out of interest, right? Not because you want a check mark, right? If you want a transcript or a check mark, your best bet is to just drop the class right now. Right? You know, these are other sections that will just give you a check mark for no effort. But in this class, you will actually have to do a lot of work in order to get, but every single second of work you put into this class will come back to repay you 1,000,000 times in your life later on, okay? Because what you get, if you get a really good value out of this class, that value is going to serve you really well. It's not just going to be a paper mark, okay, that will say, oh, well, you know, that person is 2A cleared, so they can go on to 2B or go on to some other, transfer to university and do this thing. That is total nonsense, okay? Because, they transfer to university, they're going to start at square one again if you don't know this, right? So it's better to get all this. And in fact, also, I think if possible to proceed all the way, even if you're not going to do my 2B and 2C, just do all the green quests and red quests in your own time. You got to complete it, right? Yeah, if you do my 2B and 2C, you also get credit for them. Okay, and you get credit for 2A and 2B plus 2 from now on, right? From next quarter, not this quarter. Well, this quarter also, right? I'm giving, this quarter in 2B, I've decided to give them extra credit points, right? I've decided to give them 10 extra credit points to anyone in 2B who can complete all of the 9 blue quests in 1 week, right? By the end of this week, they got to complete all of the 9 blue quests, they get 10 extra credit points, okay? So there you go. So if you were doing 2B and you had already done 2A blue quests, there you go, right? You start week 1 with 10 points in your kitty already. So that's huge head start, right? And really, it is a head start, right? Think about it. It is a head start over all other students when you actually know stuff they don't, right? If and so you can't complain that well, why did that person get more points than me? Because that person knew more than you. Yeah, so we can't complain there. And it's not like those opportunities are not open to you. Every opportunity is open to every single person. And in fact, I'm actually talking to Foothill right now to say, these lectures I'm giving you, in fact, the questing, and I've read it, everything, right? Everything to do with CS2A, 2B, 2C. Why should we just keep it restricted to only the students who pay fees at Foothill? Because ultimately it's useful content, right? A lot of people can benefit. A lot of people can benefit just attending these lectures too, if they have time. Right, it's better than watching a Netflix film, maybe. I don't know, right? So they could. So why should we just restrict it to Foothill students? So I'm talking to see if we could just open it up, right? Anyone could attend these lectures. Anyone could quest. Anyone could get points. But but people still pay $170. I think it costs $270 or $170 to do this course. And you do get value for the $170 because if you're actually at Foothill and pay $170, it's so many goodies at Foothill, right? That may be relevant to you in the Bay Area, right? You get free everything, right? Free consultation, free what is it? What is the psychological services? I don't know. They call it. This is a service name, right? And then you get free STEM center services. You get free food. You get free food. You get food. So many free things you get free, but you don't need any of that to master C++. And that's why I say that anything that you don't need to master C++, you should just be able to get it, right? I don't care because it's not going to cost me extra time and effort to give these lectures to 1 million people as opposed to 5 people. I don't care. I'm just going to talk anyway, right? And people that don't want to listen to me, they don't have to listen to me, because you can still master C++ by looking at all the online resources, doing all the quests, and everything is fine, right? So you don't have to listen. The students at Foothill are encouraged to listen for points, because they can get, they get points, and because that's one of the ways in which we can establish that, that student has actually achieved mastery of the subject, right? Because that is a reason many lecturers make it mandatory for students to attend lectures, because that is, other than the final exam, that is the best way to tell if a student has mastered a particular subject or not. Not master, you don't have to master it, is comfortable with all the concepts that were taught, right? Because if we talk about a certain concept, and then you are totally lost about that concept, that's fine. It's fine. But we don't have to rely only on a final exam question to know that, right? So a lot of these things go in, and but more important thing is that it allows us in earlier lectures to single out students and say, well, why are you hesitant to agree with that, right? What makes you think that is wrong? Right, and then we can have an extended conversation and say, that's a good reason, but this is the way it's done, and that's the reason why it's done this way, and then both people will see the sense. Now that's the reason why it's done that way. Okay, now I can see it. I can't tell you how many times we've had this exact conversation before, right? I think maybe it's on Reddit, or maybe even on lectures, maybe in recorded lectures, and students have said, it should be done this way, and this is the easiest, more efficient way to do it. And it seems like that on face value. I can tell you, right? It seems like what the student proposes is in fact the way it should be done, right? And then we say, no, that's not the way it is actually done. But the people who did these libraries, did these things in C++ at these incredible places, which have brilliant minds, they were not stupid people, right? So they must have a reason for doing it this way, right? Even though you can see as a student that it's not the most efficient way, there is a reason why it's done that way. So let's go and look at the reason, right? And then after looking at the reason, we all agree, saying, well, that is the reason that was done that way, because that person wasn't stupid, right? So they could see all the way through, and that is the reason. So even though you thought that this is the reason that it should be done that way, right? With this additional piece of knowledge, you can see that this is the way to make sense of it, right? And then all of us. So that is the reason. That's what I mean, right? When I say that, when you say it doesn't make sense, we all have to agree that the same thing makes sense. Okay, that's because as far as good sense goes, I believe that everybody has the same good sense, right? Everybody knows when something is out of whack or not. Well, maybe you don't know always, but what you think what you're looking for is sense. Does it make sense to me or not? That's what everybody's looking for. Doesn't make, maybe what you're basing your sense on, those facts, those premises upon which your sense is preconditioned, right, contingent, maybe those facts are wrong. Maybe you say, it has to make sense to me because according to my belief that every mouse has only 3 legs, okay, this thing is wrong, this observation is wrong, okay? So some other relational or argumentative structure may make total sense with that belief, but this premise could be wrong, right, in deductive reasoning, right? But so we're not asking if that premise is wrong. Maybe that premise is wrong, but we want to check if everything that follows from that is true. So all we want to make sure is just like in mathematical induction. I don't know if people are familiar with mathematical induction. 2 important steps to mathematical induction. We won't get a chance to talk about mathematical induction in CS2A. I used to do that before a long time ago, but then I figured it's actually better to talk about math induction in CS2B because they actually have to deal with the recursion, really hard, interesting recursion in quest number 2 of CS2B, right? And now since I'm going to have meetings with them, I feel it's better to talk about mathematical induction with CS2B. Because mathematical induction is very similar to recursion, right? Because recursion, there's two different parts to recursion. That's why it's very important to not play with recursion unless you're really solid in computer science, right? We don't even introduce recursion until CS2B. Lots of people say, oh, you got to code with recursion and so on. No, there's 2 very important parts to recursion. You got to understand both of them before you can feel comfortable and confident coding in recursion. One is that the logic needs to be right, meaning that, once I've got here, okay, everything I do here needs to be right. That's a logic. From here, I can go to here, 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 here. The logic to go from here to here, I've got that right. I've got the way to step. I've learned how to keep my balance when I'm standing to go from here to here, right? I know how to step from here to here. Okay, that one step I've learned, okay? one step I've learned, that is the logic step. That is, that is the inductive step in mathematical induction. However, that's not going to get you moving, right? In order to get moving, you have to get, make sure you're standing, right? And then start taking steps. You can't start taking steps when you're sitting down, right? You got to stand. And standing is basically walking with 0 steps. Yes? Okay, so you got to get the basis case. That is called the basis case. All right. When you get the basis case and you can say, okay, I've got both things right. I've got the basis that is standing, and I've also got the second step with the inductive step, which is, after I've got to standing, I know how to go from step to step. Then you've got the whole thing covered. Then you can go anywhere you want. Yes? Okay, 2 steps. Recursion is exactly like that. And in fact, it's very interesting, right? The way these things play together, and one proof runs to another, and because this is true, that's got to be true. It's so incredibly fascinating, because math induction is not only just similar to recursion in this way. You'll find that there's a lot of proofs, right? Because so where's the heart of computer science? In computer science, we're learning about computer control structures and how to put things together, right? But when we can get to the real computer science, CS2C, machine learning, things like that, people aren't asking you to make this thing for me, make this thing for me. You want to find out how to make things faster, right? So you stop from so in the beginning, people will say, make this thing for me, okay? Those are beginning computer scientists or beginning programmers, making things, okay? But when you get beyond making things, right? When you get to be an expert programmer, people generally don't ask you, or even in management positions and so on and so forth, you're generally not tasked with making things, okay? So you'll say, there's a thing that already works, right? And obviously it's being done in the best way that you would have done it, right? So, but it's not working to the best possible way. Whatever the metric is, I'm going to try and optimize cost. I'm going to try and optimize communication or bandwidth or whatever it is, right? According to this metric, it's not optimal. It's using more than its fair share of resources. So you got to go and find out where the loss is. Why is it not working as well as it should be? Okay, that is where real computer scientists come in, and that is what people get paid for, right? So people are not really paid for putting things together. So putting things together, the programmer job, the programming jobs that consist of putting things together, okay, that generally stop around 150K per year, okay, 150 max 150K. I've not seen any, right? So 150K is where putting things together. In fact, even other not just programming, okay, but where it starts getting from 150K to basically limitless, right? You can make millions of dollars from then on, right? So is to get that insight, right? That stone that many people say it takes you 10 years of programming to get there, right? So you can get to a place where you can put things together, and you can keep on putting lots and lots of things together, like that, and keep getting paid for it. You get lots of money, right? 150K is not money to be sneezed at for many people, right? So you get that, but you keep doing that without focusing on other nonsense, right? Because people, when they're doing that, focus on the wrong thing and say they get led into a wrong kind of world, right? There's 2 different kinds of worlds out there. One kind of world is focused on power, glory, position, status, power, title, job title, and shit like that, okay? So you can get sucked into that world. Or you could say, wow, I've got in a position where I'm able to learn some things that I would never have been able to learn before. Because in this position, I have access to a new kind of data feed with new kinds of patterns in the data that wasn't visible here, right? Because that requires a bigger lens, a bigger fisheye lens that can take more data in, right? So you get to say, now I can learn more. Those kinds of people have found themselves in the right kind of world to keep on growing, right? So they won't get stuck in the 150 glass ceiling barrier, okay? So those kinds of people will be able to suddenly have that mental flash, say, wow, that is really what everybody's driving for. That is what is important to a company. That is where the value is, right? So in a value creation workshop, that's where you learn. Because, profit and all these things, you can tease out really early. Those things will come out early. In any calculus, any system of a marketing, in a product, you can put the numbers in and you refine them and apply something. Okay, well, you can maximize the profit. Okay, bam, 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 like that. Okay, so that is easier. I'm not saying it's easy. It's hard, but it's much easier than actually teasing out the value. Right, the value is different from the product. Okay, or the cost or the price or the profits you make from it. The value is what makes the product more gives it more longevity. Right, people continue to use it. It takes part a part of their brain, essentially, right? So that takes a longer time to discover. And essentially, value is where a product goes to solve a pain in a person's mind, okay? So when you take meds, in SRI, we used to say there's two kinds of meds. One is called a painkiller, and the other is called a supplement, okay? And I actually added one more to that. What was it called? Painkiller supplement, painkiller supplement, and painkiller supplement and critical. I don't know. I add one more saying it's life or death, right? So anyway, going back to SRI, so the painkiller supplement is there's two kinds of solutions, right? One kind of solution is just going to be a painkiller. No, it's going to be a supplement, meaning it's going to improve someone's quality of life. Meaning, you know, if I didn't have Alexa and Amazon, I'm just going to walk over to Trader Joe's or, you know, Safeway and get my stuff. I don't care, right? But, you know, having Alexa makes it easier because I can do something else. You know, I can basically sit here and chill and just not do anything at all, just be sitting around because Alexa is going to do my shopping and the stuff is going to arrive. Okay, so so things like that are, you know, sweeteners, right? Or supplements to your life. They're not. I can live without them. I can live with that. But there are other things that, you know, you get so used to that you can't live without them anymore, right? So you can technically make your life as free as external dependencies as possible. Even you can use technologies, and, you know, as long as they're able to help you. But you can say, I'm not dependent on them. I don't have them, right? So you can. But it is. But there are some things that, you know, like painkillers, medicine, right? They talk about Pfizer and all these companies, right? So, or COVID things, they actually, they're not supplements, right? They're essential. And when you come up with a painkiller solution, okay, that will catapult you from the 150K level beyond, okay? That is where people go and say, well, you know, I'm able to have this insight about a pain point in my mind, which is obviously resonant with the pain point in many other people's minds too, right? So if I solve that pain point, make it easier for myself and a million other people, you know, I don't care even if it doesn't make any money, but it's going to end up making the lives of so many people easier and simpler and more fulfilling and useful, okay? And at the end of the day, after 10 years, they're going to come back and say, well, because of this product, I now have 10 years of life. I have 1 year's worth of interesting stuff to look at, rather than 10 years worth of video feeds that I looked at and I forgot, right? So that you could have too, right? You can say, I watched lots and lots of interesting videos and played lots and lots of interesting games in Fortnite and Valorant for 10 years, right? But if someone asks you a detail about something else, maybe you don't remember, right? Maybe you remember one particular thing, like cruise you went on and things like that. But after 10 years, if you say, you know, did you use any products that created value for you in your life? Right? Did you use a product that actually made a lasting impact that you say, you know, that actually became a part of you, right? And those are the kinds of ideas that will start emerging. When you get into a field long enough, you'll start generating value, right? Because you want to use the field and all the skills that you've learned to bring out the interesting things in you, the useful things in you that you believe could be useful to other people. You want to bring them to the use of other people through as many different avenues as possible. And you're going to use these skills. And that is the reason you want to learn new skills, right? You don't want to learn a new skill to just get a, you know, new car, a better position or a better job title. So that is the other world, right? That is the world of power, glory, and external appearances, right? So you want to enter the world of no, not power, not glory, but just happiness and fulfillment and finding interesting things to do that will just keep your, you know, wonder occupied all the time. They're saying so many incredibly beautiful things here, right? So I should be looking at these things and enjoying life rather than, you know, complaining about some silly ass promotion that I didn't get, right? Which I didn't need, right? So, you know, if it is a question of, like, you know, bread and butter, and say, if I didn't get that promotion, I'm going to die because I'm not going to get my bread and milk for tomorrow. Okay, then you got a valid point, right? But if you're just going to be a happy person anyway, right? And that promotion is just going to give you a different title or a little bit more money for someone else to say, you know, then that really is not going to add any value to you, because you're going to forget that in 15 years. Right? So you think about what things will add value to you, and you'll see that, you know, this is a great opportunity. You're in the midst of a great bunch of people who have all gotten together to learn things, not for the sake of a transcript, I hope, right? So I hope you're not here to just get a check mark on your transcript. If you are, or if you have friends that you are in this class just for a transcript or a check mark on their grade paper, tell them to drop the class, okay? Because, you know, they'll get it, but they'll get it regardless of any class they go to. In my class, they'll get it after doing a lot of hard work, okay? But that hard work, believe me, right? Maybe I'm wrong, right? You have to disprove me, but nobody has disproved me, right? Believe me when I say this, is that this hard work will come back to repay you many times over later on. Okay, it's not like this work is, think about this as a skill you're going to learn. Okay, that is the reason people go to community colleges. People go to all these other brand name colleges to get the paper. Okay, you can go to xyz.edu and say, I graduated from xyz.edu. Here's my transcript, and here's a video of this president of the whole world giving me the certificate. Yeah, that's all total nonsense, right? But you pay a lot of money for that too, right? But the reason people come to community colleges is not for the piece of paper, right? Because we don't place value on the piece of paper. Right here, the value is placed not on the actual credential, but on actually importing value and education to you. That's why you go to any other class too, right? You go to ceramics, or we have a fantastic studio, right? Much better than many other professional institutions too, right? So acting and English, and there's all of these. We have very accomplished professors who basically say that we have been in this field long enough to understand its nuances and appreciate it, right? Now, I just want to make other people appreciate it too, right? So that's what they're there for, right? Most people don't even care about money, right? They just want to be able to share knowledge. And so that's why community colleges exist in the United States. And they have the equivalent of community colleges in other countries too, right? Yeah, but that's what the thing is called, right? In the US anyway, it's called the community college system. And here, the goal is to provide knowledge and education to anyone who wants to have education. Just like if you go to a hospital today, right? In modern countries, so you go to a hospital, you don't have to have an ID card. Tell me if I'm wrong, okay? You don't have to have an ID card, okay? You just be a tramp, right? And just go to a hospital and say, I'm in terrible pain, I'm going to die, and they'll take care of you, right? They will take care of you, and not like half-ass care like they would give a hobo, right? You will get the exact same care from the hospital as if you were the president of the United States. Well, it's going to be different for Joe Biden because it's going to be a whole lot of security and shit like that, right? But I'm saying that if you go in, you're going to get the same care as maybe Jeff Bezos or Steve Jobs walking in, right? So everybody gets the same level of care here, and they don't ask you for the money. Right? Because hospitals are there not for, to say that we serve this grand person. Wait, we serve this person? No, we just served a human being, right? We made someone's life better. So like that, community colleges are here to make your life better. And by giving you what you want, right? You've come here asking for knowledge, I hope, right? And you will be given the knowledge. Whether you take it or not is up to you, obviously, right? But we're going to try our best to make sure you take it and enjoy it too, right? I don't know. That's wow, I've been talking for such a long time now. Why is it 9:17? Okay, all right. Honestly, I think you guys should take over and start. You can share an iPad screen or even start coding. Not coding. You've got to share a screen and start talking about numbers, bits and bytes, and ask questions amongst each other. And I can chime in. Okay, and chime in. Ask questions, saying, "Hey, I'm struggling with this. Hey, you guys want to try? You should say, right? Maybe Zach says." Hey, you know what? ZACH. Does anybody want to try adding up their name to mine? Hopefully a small name like Sam or or Ing or someone like that. We actually had a student whose name was one letter. Oh, gee, I forget. Wow. Very long time ago, right? It's one letter name, and I asked her if it was an initial or the letter or the name itself, and she said it was a name. It was a full name and it was just one letter. How is that? Is that possible? I think we should, I don't know. Maybe we should just Google and find out if there's one, and you can totally have a great deal of fun at parties. And you say, my name is A. Stanley, all right? And you say, hey, I didn't know you always pronounce your name with your initials. And say, no, that's not my initial. That's my full name, A. All right, something like that. That would be really cool. Interesting conversation starter, right? Okay, so you can say, I got a name. Does anybody want to do base 27 edition with me, right? Add my name to theirs and find out, right? Really challenging would be, finding a product of two names, right? In base 27 is going to be hard. You can also try converting from, to hexadecimal or octal. That's also fine. Okay, my name in hex is my name in octal is. That's fine. Or you could even say, well, here's a pattern in binary. What is the corresponding value in decimal? Oh, here is the decimal number, 47. What's the corresponding bit pattern, right? So all of these things you can try and figure out. And if you have a question, all you have to say is, hey, Anand, can you help me? All right, that's all you need to say. All right, I'll be more than happy to, to jump in and explain. right? Walk you through one of those steps, right? I'll say, well, this is what we do, all right? And this is how we get the answer. And that's the reason we get the answer, right? And this is the reason we did it this way. This is the reason we said we're not going to use sign magnitude or two's complement or things like that. So I can explain those things if you want. Hopefully I shouldn't have to, because all of these are in previous weeks, previous quarters lectures. You should be able to just go pick up any of those lectures for the corresponding weeks. Luckily, I think every quarter we have the same topics covered on the same weeks. Coincidental, really. I haven't been planning it like that, but I think what's been going on is that students, on average, seem to be mastering the material at the same rate, regardless of which quarter, right? So we're proceeding at the pace of the students, right? Not at my pace, because I have, in the syllabus, I have this blue table where I say, week 1, week 2, and so on and so forth. There's just one suggestion, but that's not the pace I'm going at, right? I just use it as a guide, and a fallback measure, and I always take feedback from you guys and go at your pace. So if you say, well, let's do this and so on and so forth, we just let the program and what we do dictate what we're going to do next. And coincidentally, in fact, you know what? The sequence of topics is not due to me. This particular sequence of topics, both in CS2A, 2B, and 2C, are the result of many, many years of Michael Losef. I don't know if you guys even remember Michael Losef, or know that there was a professor called Michael Losef here, right? He was the person who retired just before I joined. Well, we overlapped for 1 year, and I took over a lot of stuff that inherited a lot of material from him, right? And also a lot of really, really good advice, right? So I'm indebted to him in many ways like that. But anyway, so this particular sequence of topics, a lot of people dismiss it. Even in Foothill, other professors may sometimes say, no, that Michael's materials and his sequence of topics, we're not going to do it that way because it doesn't suit my students. I don't know, right? But so far I've found that particular sequence of topics, it just can't have come about by chance, okay? Because it's not even the sequence of topics in the textbook. It's not the sequence of topics in textbook, and it's because the topics are coming from and not just 2A, right? 2A, 2B, and 2C. Now I think my hypothesis is that Michael must have started out when he first started lecturing. That was back in the 1980s, right? He must have started lecturing with some sequence of topics, not like now, right? And then over a period of several years, right? At least 10 years, that sequence of topics, he has been changing it, right? And he is refining it based on student feedback and what he's observing in students. And what he's settled on after 10 years of work is that particular sequence of, and that I think is the reason why I am able to just blindly take for granted that I just take a sequence of topics and poof, out of thin air. Coincidentally, everybody's saying all the students seem to be marching along at the same pace, right? And it just works out so beautifully. So that particular sequence of topics has actually been curated. It's not like pulled out of thin air, and it's been working so beautifully. That's why all our YouTube recordings are also being able to be categorized by week, because this is week 1. You can always go to week 1 lectures from previous quarters, right? And you'll find pretty much the same material. And in fact, you'll find in previous quarters, we didn't talk about so much fluff, right? We actually got right into data representation issues on, in minute 1. Well, maybe not minute 1, okay? So we got into data very, very early on, and did a lot of data representation, transformation, number changing and division in binary, converting from decimal to binary and binary decimal, hexadecimal to binary, all these things, right? We did so many different examples of these things. You'll find more examples, more interesting discussions in those videos than if you were to go to YouTube, for example, and type in how to convert from hexadecimal to binary. I'm sure you'll find like 100 videos, right? 100,000 videos even, right? Of different people telling you how to convert from, right? And you have different kinds of insights. But I find that people who watch our videos and then go and do that search, they benefit a lot more, because they understand the concept in a particular way that actually makes, I don't know, a different kind of sense from, because what happens, I think, in YouTube videos, I think this is what it is, right? In some of the YouTube videos that I've seen anyway, many of the people who are teaching don't seem to approach the topic holistically, meaning that they understand the topic, right? And they explain it very well in one particular way. And they do it very well in one way, okay? So if you understand it like them, it's fine. But if you go to another video, they may explain the same topic in a completely different way, and that's also correct, right? They understand it in a different way, and so there may be two different explanations. And many times we find different ways of doing the same thing on YouTube, and that could. But what we do in our lectures, I think, is that we try and look at it more holistically and say that doesn't matter which way, they should all work, right? Then if you go and look at the YouTube videos and say, well, let me look at that video which is supposed to do it that way. This video is going to do it in a different way. So that way you won't be surprised. But if you don't, if you go straight to YouTube and say this is the way to do it, you may think that's the only way to do it. And then you may see another video that does it a different way, and you think that's probably wrong, or that's not the way that I should be learning to do things. That's wrong, right? You should be learning to do things in all different ways, not just in one way, right? Builders will learn to build things in one way because that's their job, right? If you learn to build things in one way, you're done, right? You can just go knock out many buildings and get paid for each building, right? But an architect needs to learn to build a building in many different ways, so that he can say, no matter who your builder, I'll design a building that you can build, right? So that's what computer scientists are. And so we don't want to learn any one particular way of doing things, but we want to learn the general principle, abstract it out, and look at it from one level higher, not from here, but here, and say, this is what we're trying to accomplish, right? So there's different ways of doing it, rather than get locked into one particular way of thinking, saying there's only one truth, there's only one way to do things, there's only one thing that is right, every other person is wrong or believes incorrectly, right? That is a more limited, more childish way of thinking about it, right? Not a less mature way of thinking about it. So when you abstract things out, you'll see that you can actually find that all of these videos on YouTube, right? Different ways of saying exactly the same thing, right? Not that one person is better than the other. Each one is trying to explain it in the way that they think is best, and that's what I'm going to try and do too. But what I try and do is also, I think, touch upon many different ways of doing things, right? Or at least say this is a reason, and you can do it in this way or another way, right? So sometimes I do that. So that may be useful. And some of you students, that's why the videos are useful, because you can see different students saying, one student may do it one way, another student may do it another way, which even I might not have thought about. So, and then you can say that's really cool, right? So you get two different perspectives of the same problem. That is usually how learning happens, right? Learning does not happen by learning one perspective of everything, right? That's just like tracing one path to a graph, just one path. That is not learning, right? That's just finding the way to a destination. And learning is just saying, no matter where you drop me, I can find the way to the destination anyway, right? So be able to say that there are many different paths, right? And no matter where you drop me, I should be able to find one, right? So, and when we get to that state, I think computer science, any learning in general, will be great fun. I don't know. That's my spiel. Do you guys want to? I'll be around if you want. If you feel that I'm cramping your style, you shouldn't really, right? I can just turn the laptop around so I'm not looking at the screen. You're basically looking out at the yard or something like that, and you guys can have a conversation. And I will not be in looking mode, but I will just be in listening mode, so that if you want me to answer any of your questions, if you have a question to me, you just have to call me, okay? I'm just going to be around. Is that okay with you guys? Or I can just be around here. You can ask me a question right now too. I don't care, right? I can just be sitting here, not doing anything. I might spook you guys just by if I'm just sitting here and watching you guys, and you guys are going to be coding, and I'm just going to sit here. I don't know. That may not make for a pleasant coding experience or a discussion experience for you. So I'm happy either way. Okay. Anyway, at the end of the day, all I want is for you to just be totally comfortable with data representation, even if it means that this week you're going to dedicate yourself completely. Okay, completely. Dwayne just admitted. I didn't even know Dwayne left. He was right here like 5 minutes ago. Where's he gone? Oh, it looks like even if you leave the meeting, then you get into the waiting room when you come back. That is like totally not good. Okay. Yeah, I got to change this. Okay. Yeah, that's basically it. Tell me, are you guys okay? Are you happy with the way things are going to happen? Because as you can tell already, this class is set up differently from other classes you may be enrolled in or have experienced in the past, right? Even in school or college elsewhere. right? It's different, a different experience altogether, right? So you guys need to be happy with this and interested in doing it this way. The pros of this approach is that you get to reuse a lot of this for credit in 2B, right? In my section, unfortunately not in other sections. Okay, this more important pro from here, from that, is that all of your effort, real, true effort in this class will be totally worth it. Okay, I can guarantee that. Okay, each of you, if you put in your 100% effort into this class, will go on to make some earth-shattering product in future. Okay, in a few years, you're going to make something really great out there. Okay? And but you just need to invest yourself completely, because I'm able to teach you. I'm able to get you. I'm able to help you get to where you want. Okay, so I can help you do that if you're really interested. Okay, even if it means extra time or guiding you through extra work that is not really directly CS2A, but if you get all the way to CS2C and say you're comfortable with CS2C, and now you're able to take on a real big project that you have in mind with Unreal Engine, right? So which I have this game that I need to build, which needs this blueprint to be built first, and there's all these scenes, and the C++ code needs to be attached to these objects. I'm very happy to help you all the way, architect all the way, even point you at the right tutorials, FPS games or whatever it is, so that you get comfortable, and then you can start working, and I'm able to guide you through this, or even set something up in the cloud to to handle something that you did in C++. I'm very happy to do that, right? For help you, teach you how to do that. Set up a web app with JavaScript and so on and so forth that can eventually, run C++ too. That's also fine. All of those things, I'm happy, right, to teach you guys. At the end of the day, like I said before, in a few years, anytime I see one of you guys' names out there in a newspaper, I'm gonna be happy, right? You'll be happy. Hey, I know Sean. He was in my class. Yeah, look at him there. Okay, all right. And then maybe on your corporate blog, you can have a video saying, "Hey, this is me as a student." There you go. Watch this YouTube video. All right. So this is our CEO, and so all those cool things you can do. All those things. I'm happy. I'm very. I can teach you these things, but you need to put in the time. Okay. So don't treat this as just another check mark. I know that a lot of students do enroll in classes for check marks, especially, even not just community colleges, right? I've talked to many students going into 4-year colleges also, and when I ask them, they say, I enrolled here because that's what my parents said I should enroll, or that's what all my relatives are doing, right? Or everybody in this area in Silicon Valley is doing computer science, so I should be a computer scientist. All wrong reasons. And so there are people like that, but find the right reason, right? And again, not being set up for C++ at this time in your life does not mean that you are a failure in CS2A or CS or C++. It just means that at this time in your life, C++ is not your cup of tea, right? If I wake you up at midnight and offer you a cup of coffee, maybe you're not going to drink it. I say, I like coffee, but I'm not going to drink it right now. Yeah. So like that. You may not hate C++, but you may not want C++ right now, because right now your mind is set on how you can create this incredible screenplay, right? So you want to do a class in creative writing or English, right? Or do something in ceramics. I don't know, so many different places, right? Music, so many different classes here. So all perfectly fine, but you got to follow this is your chance. And again, you don't get this chance later on when you're working, but you get a chance now when you're not working, is to experiment and find out what you're really passionate about, and just pursue that with 100%. That is the thing you don't get later. You do not get an opportunity to put yourself 100% into something, right? Even now, I have students even in community college courses, right, who have enrolled, who say, I love this, but I cannot put my 100% into it. Yeah, okay. All right, I know that's sad, but at least they can put something into it. But there are students who also can put 100% into it, right? And they should. If you can put 100% into it, meaning that you can postpone something else, right? If you have to do 2, that's what I mean, right? So if you had to do 2 courses and you had 1 year to do it, right? And some people might say, I'll do both of them in 1 quarter and then chill for the remaining 3 quarters, right? I think that's a worse strategy than saying, I'll just do one for 1 quarter, 100% of me and 100%, and then I'll chill for 2 quarters, okay? So that's a much better strategy, right? So don't just overload yourself with 20 credits. I don't know, 20 is the maximum, I think. No, I think 24. One time, not now, in my face-to-face classes, I had a student who had enrolled in 24 units. Okay, I don't know if any of you have enrolled in 24 units, but I can't imagine myself doing 24 units in 1 quarter. Okay, that's really a lot of work, because unless they, they're exceptionally, they don't sleep at all, right? That's possible. But anything more than 15 units is really, you gotta make sure that 15 is the limit of this is my experience, okay, for ordinary students. 15 units means you can still have a social life, okay, which means you can go out and party, have a drink from time to time, and take it easy, okay, you can chill. 20 units is possible, right? Lots of people do 20 units, and they get through with even A's and things like that, okay? But it just means that with 20 units, you got to sacrifice something, and I think many of them sacrifice a social life. Okay, it's fine, right? But you got to be aware of that. You got to be aware of, I'm going to be doing 20 units next quarter. So next quarter, I'm not available for any parties, guys. Okay, so don't PM me, right? Next quarter, I'm just going to be hunkering down, right? Doing something. So that will be fine, and I think all your friends will also appreciate that, right? But if you do, yeah, and I think I should tell them, 1 quarter, I'm out of reach, right? You can even tell your family that, right? You can tell your family and saying, for the next 3 months, I just want to give myself 100% to this. So please don't give me lots of chores, right? Or even don't expect me to be unduly kind, right? So don't, just be more tolerant of me if I'm a bit rough around the edges for the next quarter, because I'm going to be giving myself 100% into this, right? Lots of people are tolerant. If you just give them, even managers and employees, I find, right? So if an employee says to a manager, I just want this allowance, right? And managers are reluctant to do that. And I found the answer to that once upon a time in a company when I was working. And a bunch of employees said they wanted a raise. And then I went and asked the CEO, saying, well, we have profit, why don't we give them a raise? And he said something which I think makes business sense, because I'm not a business guy, so it doesn't, gel that well with me. But I think I just assume that it makes business sense from where he's looking at things. He said that, well, I don't want to give them a raise. I know they've done a lot of hard work, but I want to give them all bonuses, right? And the bonuses will be more than the raise, but they will be one time, right? And that will keep all the employees happy because they get more money, but it's not going to be part of their payroll anymore. Because once it's part of the payroll, it's like oxygen. It's like air we breathe but do not see, right? So without the air, we're dead, but we don't see the air. And like that, he said, we don't want the money to become like oxygen, right? We give them enough to keep them alive, but we don't want to give them invisible money. So if you give them, right? So, and he said, well, I don't know. I said, well, I don't know, if that's your take, that's fine, but they do need to get, because I said, the bonus is fine, because, if they don't like it, they'll just take the bonus and leave. It's like they got a raise and they left after a year, right? So I said, we give them a bonus, but we'll have to keep them happy anyway, because if they're not happy, they're going to leave, and the bonus is going to be the same as they're getting a raise, essentially from their perspective, right? So I kind of settled for that, and I could see that they had some sense, because when he goes to present the company financials to the investors, because in the board meeting, that's what I saw, right? So it's not like I can make that person an evil villain, because I got to see things from that person's perspective also, right? So I tried to see what he was thinking when he said that, and so in order to know fully appreciate fully where he was coming from, I had to imagine that I was him and I was in the board meeting, right? So I tried to imagine what was going on in the last board meeting when he had to make a presentation, right? And for me, I was his employee, right, in the board meeting, but he was the boss, and he was doing a presentation to all the investors. And so my presence in the board meeting at that time, after several years, when I thought about these things, I found was completely different. My image, my mental image, my picture of the board meeting and everything was completely different, because there, my primary goal was really to say, am I impressing my boss? Am I giving my boss everything that he needs to impress his boss? Right? And so I was thinking about impressions, and is what I've given him enough to get him more money? Because investors, that's what they all think. It's all finance, right? The point, it's all money. But then I thought more about it. And that's when I thought, well, now let's look at the content of what this guy presented on screen. Not just the fact that he presented and things like that. But let me look at what he was trying to say to the investors. And then I saw that what he said to me actually made total sense, right? Because what he showed to the investors is that this is the payroll we have. This is the expenses, right? And the way the investors interpret that is a payroll expense is an ongoing expense, which has to be billed continuously, right? And so even a small amount increase in a payroll it results in a huge amount in that calculus in that sheet, and the investors could go, that doesn't work out, right? Your company is going to run out of money in 2 years. I can't put any more money, good money into bad, right? So I could see where that was coming from, right? So, and I think, and this was an observation also in programming, right? One of the students, I think his name was Wolfgang, right? A couple of quarters ago, he made his observation in a CS2C thing, saying that after a certain point in these quests, you'll start getting an additional report, right? Right now, you only get the build report, which tells you, whether your compilation succeeded and how many trophies you got. Yes, I don't know, you haven't started yet. But when you get to CS2B, you get 3 of these reports, right? You get the build report, your compilation, and you get your trophies list, right, which is your output, and you also get a memory leakage, right, report, which says where your memory leaked, right? How much of the memory you asked from the operating system but didn't give back, which is really serious in C++. So that's your memory leak report, and that is also provided. And because lots of students went from CS2A to 2B and 2C, they just get comfortable with the first 2 and don't even bother looking at the memory leakage report. That was the way it was for a long time. But this student said, I have these persistent pointer errors, right, in C++, memory leakage issues, and I can't seem to figure it out. So let me just on a whim, look at what the memory leakage report says, right? Because previously, a lot of students really get frustrated and say these memory reports, memory errors in my code, not getting trophies, really, really frustrating, not giving me enough information. It's bad example, but bad, lab or something like that, bad quest. That's, or, trying to do something else, like trying to impress the boss. And, but then this student said, no, I'm going to look at the memory leakage report. And they found lots of really, really interesting and useful information in there, and said, I spent 5 hours looking at the bug, but if I look at the memory report, it tells me exactly where that error is right at the end. I just need to understand what it says and tells me what went wrong and why that error happened. And so after a while, we start looking at these things and see exactly the same parallel, I think, right? So initially, we think that we're doing it for something else. We just want the trophies. We want the money or the funding. We want the trophies, no trophies, improve things, no trophies. But eventually we say, it's not just the trophies. I want to know what's going on. I want to know why the memory is leaking. I want to know where I'm not deallocating because I thought I was so clean, right? That's usually where most programmers get a lot of fulfillment, I think, because you write programs and you say, this is the cleanest program I've ever written. This is the cleanest program any guy has ever written in the world, because every single bit that's being allocated, being deallocated, there's no way anything could go wrong, right? This program could be running for 1 billion years and it will not grow in memory by even 1 bit because nothing is being allocated. It's not free, right? Because if you allocate something and don't free it, it's okay if your program dies, right? If your program dies because the operating system could say, this program asked for resources, but it didn't give it back to me, but that program is not there anymore, died. So these resources don't belong to anyone. I can free it. Yes? The computer can do that, right? But what happens? What happens if you're a program that has got that, genetic engineering, which says you're never going to die, right? There are programs like that, right? The daemons and Unix and all the programs that never die. They are called daemons, right? So the programs that are in an infinite loop. not doing everything, doing things all the time. They're just checking for input, right? If something happens, they're event-driven programs, right? So if something happens, they're going to react. If it doesn't happen, they're still alive. They haven't died. So those kinds of programs, they're there all the time, alive all the time. So those programs, you got to be really careful that you don't allocate resources that you don't release, because when you allocate resources, don't release them, the operating system cannot release them to other people because it says the owner is still alive. Right? If you buy something and you don't use it, and you can keep it locked up in a bank, right? And you're alive forever and ever and ever. That's also going to stay locked up forever and ever and ever. That's a memory leak. And so when programmers write programs that they think are like, because you get proud, right? Pride is not something that should creep into our programming, but that's something that happens during the early stages of programming anyway. Right? Get proud and say, I could never write a program that has a memory leak because I'm so careful. See, my programs are so bulletproof and clean and so on and so forth. Because you get a kick out of it too, right? You get a kick out of writing really, really complex algorithms that don't look right on face value, but they actually do the right thing, right? And you can prove that it works also. So and you get a kick out of that. And you do that, but you do notice that there's a leak, right? You do not, and that is a juicy tidbit for most programmers. Okay, they'll say, wow, okay, all right, how is that possible? How is that possible that this program that does not leak memory anywhere, right, according to me, is still leaking memory? I got to find out. That is a really nice piece of, and right now it may look frustrating and bad, but lots of people actually look forward to those things and say, well, that's something to keep me occupied on Tuesday, right? So I want to get to the bottom of this, because at the end of the day, at the end of that, my program will be even stronger. Because this thing, which I thought was impossible, has happened, but even that is not going to happen anymore after I get to the bottom of that, right? Every time you solve one of those, you feel an incredible high, right? And because your program gets stronger and stronger, more usable in many ways, it won't die in the hands of users. Ultimately, that's what everyone wants to write programs that won't just surprisingly die, bam, like that, in a user's hands. Okay. Wow. I never gave you guys a chance to talk. There's only 5 minutes left, 7 minutes. You know what? You guys want to talk on your own? Well, this is fine, right? I'm just going to.
So, Professor?
Yeah.
I have a question. So where did you go to school?
I went to school in India.
Oh, okay.
Yeah, you may not recognize. Long time ago. And then I did a postdoc on the East Coast, here in Baltimore. That's why you have a reference to, I thought that's why you have a reference to Baltimore in one of the quests in 2C. You have a reference to Baltimore. Well, I have a lot of fond memories of the place, right? Even though a lot of people may say it's a horrible city, right? But it's ultimately, everything boils down to the memories you have of the place, yes? Yeah, well, you can ask any question, right? Personal questions like that, like Zane, it's fine too. Or you guys can talk amongst yourself. You can say, talk amongst yourself and say, hey, are you having fun? Or what's your background? Are you a Python programmer? Because I know a lot of Python programmers enrolled in CS2C, right? The C++ track. I don't know why. Even last quarter, a lot of Python programs. Because the trend, I'm pretty sure it's the other way too, right? Because right now, I think the fashionable language, as they say, right, is Python, and everybody wants to be doing Python, mainly because of the tool sets, right? Toolkits, lots of toolkits available for Python. And but really, many of these toolkits are written in C++. And also, knowing C++ as a Python programmer, I don't know, this is a hypothesis, all right? I'm pulling it out of thin air. As a Python programmer, knowing C++ is beneficial because when you have something in Python that should only be done in C++, you have a really, really good intuition of whether there is already a Python library for it or not, right? It saves you like hours and hours of searching on the internet and also weeding out all the bad libraries. Because, these days, anything you want to do, you can find a library, right? Whether it's Java or Python or C++, doesn't matter. Anything you want to do, you can instantly find a library within 10 minutes, right? So the challenge for most programmers is having located lots and lots of libraries, is to find out which one is actually trustworthy and usable in your program, because you don't want to pull some random stuff out there and put them in the program, right? Because if if that crashes, your entire program crashes. So the quality of your stuff is contingent on the quality of stuff put into it, right? So you want to take only reliable programs from out there. So yeah, so Python programmers, especially in Python, I'm pretty sure, because I'm not a Python programmer, but I'm pretty sure there are so many libraries in Python these days, right? And so it's very hard finding quality libraries, except for tailor-made, except for common areas like numerical analysis. Okay, everybody's talking about NumPy and things like that. NumPy is written in C++, right? In fact, in CS2C, you will be writing a routine that will actually go into, that could potentially go into a NumPy, right? You will be writing a matrix multiplication routine, which I'm pretty sure is available as a sub. I don't know. It's basically a cubic algorithm. I haven't used NumPy that much anyway, obviously, right? But there are so many libraries, right? So for graphics, maybe there are standards you can use, but there are many other things for which standards haven't emerged that you still need to use Python libraries for. You don't know. Just looking at the comments on Stack Overflow don't seem to be cutting it anymore, or at least I find. So, but knowing what is possible and what is not in C++ will help you in Python because I think it tells you this is something that if a library exists, can only be done by a competent C++ programmer, right? Not some random guy who just threw things together and got a library together. I think that kind of an intuition somehow bubbles up so that when you have a task in C++ that needs to be converted, it needs to be done in Python, and you know that it's better to do it in C++ than not in Python, and and you get a really good intuition that it's a standard thing, lots of people are going to do it, and already, right? 90% sure that there is a good library out there that someone has already done it and you can pick it up. I think that's how it helps. But even otherwise, right, getting to the bottom of these things, nuts and bolts, bits and bytes, ends up getting you a really solid intuition about algorithms, right? This is really the meat of computer science, it's algorithms. And because it doesn't matter if it's an interpreted language like Python or JavaScript or Java or a compiled language like C++, it doesn't matter when it comes to speed. It's exactly the same considerations. A program that is slow in C++, it is still going to be slow even in Java, right? A program that is slow in Java or Python, okay, is still going to be slow in C++. A lot of people say, I want to learn C++ because things are faster. That is the wrong reason, because that is wrong. Things are not going to get faster just because you go to C++. You just get the hardware win, right? But what makes a program faster is not improvement in hardware, right? That gives you some, Andrew's law or whatever that thing is called, right? Moore's law. But the real speed improvements come from improvements in the software, in the way that you do these things. As you will see in quest number 2 or 3 or 4, be solving the Fibonacci sequence problem, right? And multiple ways to do this. You can get the answer in the wrong way as well as the right way, but the wrong way will cease working at some point very soon, right? But the right way will not cease working. It'll continue to work no matter where you go. So it's trying to find out which one is better. That is where. So, and in the wrong way, you can say, well, I can calculate Fibonacci of 60 on this computer, but this computer is not fast enough for Fib60. In order to get Fib60, I need to go to a bigger computer. There I can get Fib120 with the same amount of time. So my problem is not the software, it's the hardware. The hardware needs to get faster for my program to run. That is the wrong way of looking at things. And someone who says that is guaranteed almost, right, until they change their mindset, to not become a programmer. That person cannot become a good programmer, because the speed improvement that you get from hardware is insignificant compared to the speed improvement you can get from software. Because what happens is that in the inefficient way of doing things in Fibonacci, you're just wasting an incredible number of CPU cycles just doing nothing at all, or just doing repeated nonsense. You've done something, you're doing it again and again and again, like billions and billions of times, right? Is it better to get a faster computer to do all the useless things, or is it better not to do the useless things? So that is what software equips you, right? So in fact, on LinkedIn, someone posted a note or a post some time ago saying, oh, we've invented this incredible procedure for converting carbon dioxide back into, reducing carbon dioxide. And this plant will do that, take carbon dioxide, convert it into carbon, and so on and so forth. There's lots of lossage and lots of energy need to be fed in and so on, nonsense. But it's the same as, plant a tree that does it, more efficiently, in fact, right? More efficient way of doing the same thing without putting a lot of work into it. I don't know where we're going with that, but yeah, essentially you're saying if you can do something the easy way, do it the easy way, right? Don't try and do things the hard way just because you can do it that way. And that's not the way to do it. Like not in C++ anyway. So yeah, programmers who say that I want a faster computer, they can do it. They say, if they say, no, I don't want a faster computer, let me look at my algorithm to see if there's any useless things I'm doing, right? Useless things that I can take out, because that's the best way to make things faster. That's, in fact, the way that people make money in computer science, right? You can get a fast computer and make a lot of money in computer science, right? You can get a super duper fast computer. Because one time ago, renting some place out. This is a guy who, making lots of money on Bitcoin by mining using a lot of electricity at home to convert them into Bitcoin, essentially. Because Bitcoin mining has gotten so commoditized now that people have basically boiled it all down to CPU cycles and the electricity you burn, right? On graphics cards you use and so on and so forth. And so it's no use doing these things. You're just wasting a lot of energy, essentially. You can do these things more efficiently by not doing the brute force technique. And that is the reason we learn computer science. Is that enough? But yeah, you guys can basically talk or drop off, talk until you drop off. That's fine. I'll stop the class as soon as you guys or guys say we're good to go until Thursday. On Thursday, what we'll do is, unless you have questions of a general nature, let's actually start with problems and data representation. Okay, so hopefully some of you can come to class already on Thursday with a couple of examples of problems you want to work out together on a shared whiteboard, either mine or your whiteboard. It's fine, right? Data conversion, conversion from one base to another, choose complement, right? Anything in module 0 that you find confusing, or even interesting things in your name, right? Converting your name to hex and pronounceable names, base 27, all of those things. We'll start as soon as possible doing that. Today being a first lecture and all, we didn't get to do a lot of that stuff, but hopefully I answered a bunch of bubbling questions, not explicit questions already, but questions that may bubble up in your head eventually. And also tell your other classmates who haven't made it today to class also that this class does in fact require a lot of work, but it will be worth it, and they should be prepared for that. And complete the syllabus quiz and do the posts on the subreddit, okay? And do the posts under for data representation. Don't do it in the foothill flare. Do it under the building blocks. There's building blocks, the Lego bricks, right? Building blocks concept. Put it there, saying, hey, data representation, this is what my name is. Something like that. That'll get a conversation going, right? And then you can have people join in and say, and you can also generate more comments on your posts, all these things. And keep this in mind, okay? In the future, when you're applying to companies and want to work somewhere, everybody's just looking for good colleagues, okay? People who are interactive, right? Talk about interesting things, happy to help you, right? Happy to be interested in your problem, right? Many people are not interested in your problem. Many people are interested in their problem and explaining it to you, right? So people are interested in hiring other people that are interested in listening. People are interested in, or working on other problems or interesting viewpoints, all these things. So if you keep that in mind, you can start generating that profile already, because here's your opportunity. You have a brand new, as of today, hopefully, brand new Reddit profile that you've created for this class. You've got this YouTube window into the world where you can actually make your presence. Okay, so think about ways in which you can leverage this and turn this into a huge asset for you in future, right? Because You want to say in the future, you want some bunch of people saying, hey, you know, that person, she made a lot of really, really cool comments on that forum. I wish she was working here because I think we can have a lot of really cool, you know, water cooler conversations with that kind of person. We can solve these interesting problems we had because that kind of different perspective outlook is what we're looking for in this company. So those are the kinds of things that you want other people to notice about you, right? So here's your opportunity. So rather than complain about the YouTube saying, well, you know, I got to have my camera on, I got to be attentive all the time. No. Don't look at it as a liability. Look at it as an asset, right? Here's a chance you can get. Because in art, I don't know if you've done art, but if you want to apply to an art graduate school, you got to have a big portfolio, right? You got to go, you know, say, hey, look at this website, all of that under there, I've done it, right? So you can look at all these pages, or you can look at all these drawings or acting, things that, what do they call them? One act, not one act. In acting, you have a thing where soliloquy. So I think it's a soliloquy, right? Every actor has to have one soliloquy up their sleeve, at least one, right? Many of them have 2 or 3. A soliloquy isn't a soliloquy? Monologue. It's called a monologue, right? Every actor has to have at least 1 or 2 monologues up their sleeve, right? If you're an actor of any worth, meaning they pick up a passage that's delivered by only one person. There could be other people in the scene, right? But they're not going to be there because when you go to an audition, they're going to say, do a monologue, right? And you got to pick that out and do it, imagining that there are other people in the scene right there. But they won't be required to act, because they're not part of the, they don't have any speaking parts, but you have all of the speaking, and that's your monologue. And so if you want to go to Hollywood, right, you got to have a portfolio of these monologues. You can't just go, hey, I just came here from, Los Altos, give me an acting gig right next to Arnold Schwarzenegger, right? So no, that doesn't work like that. So you got to have, they'll say, shows what you got. So act, drawing, all of these things. Computer science, it's an art, just like that. This is your chance. Right? In art, they give you a chance. In ceramics, they give you a chance to create a portfolio. Every class, they give you a chance. Music, Eric, right? They give you a chance to create your own portfolio so that in future, when you go to an employer, you can say, this is my portfolio. So this college gives you an opportunity to do that. So in computer science, you can consider this class 2B, 2C, chance to create your CS portfolio. And take that and spin that to your advantage, right? And you'll find it's a fantastic asset, right? It'll keep coming back, and it's like compound interest. Once you put it in the bank and forget about it, you're just going to keep getting a check in your mail, right? Like dividend from some big company. This just keep coming. You don't care, right? Well, you care maybe, right? But even if you don't do anything at all, it's just going to keep coming. And
Hey, I had a question.
Sure, yeah, Sean.
Yeah. Is a lot of this class going to be synchronous? I thought it was a lot of it's going to be asynchronous, and then
No. CS2A is synchronous.
Oh, it's completely synchronous?
Yeah. So we
Okay,
have a
okay.
lecture on on Tuesday and Thursday. Every Tuesday and
Gotcha.
Thursday, right? And you have to try to come to every Tuesday and Thursday lecture, because these are the only times when you can get a live coding opportunity. And yeah, not everybody may get a chance to do live coding, but you should try. If you tried to get a chance and didn't get a chance, that's fine. You'll still get points, okay?
Professor, I have a question too.
Keenan, yeah.
So when we're converting our names into hex, are we converting like the letters into decimal first and then converting each letter?
No. Yeah, thank you for asking, Keenan. No, you're not. No, each letter in your name is basically a digit, just like, so we didn't go into the details, but maybe we can do that next class if you want. But A stands for 1, space stands for 0, right? So if you have, A, B, a number, AB, now let's say KE, KE, K stands for IJK, K stands for 11, E stands for 5, yes? So if you had a name, KE, just KE, and your name was KE, that value is, E is 5, so it's 5 times 27 to the 0, that's 5. 27 to 0, is that 25 plus, what is this, 11? 11, yeah, 11 times 27 to the 1. So it's 11 times 27, that's 287. 287 plus 5, that should be 292, right? So KE should be 292 in decimal. Does that make sense?
So I'm converting it like that to decimal and then to hex?
Yeah. Oh, that is your question. I'm so sorry, Keenan. Yes, yeah. Okay, give me 1 sec. Let me think about this. Okay, you want to convert it? I think that'll be a whole lot easier. Yeah,
Okay,
convert to decimal
okay.
and then to hex. Technically, you can also convert directly to hex. It's going to be harder. It's possible. If anyone wants to have a extended discussion in the forums on saying, right, you'll get extra credit for this. I can guarantee, right? So we talked about how you can convert from base 27 to decimal, but can you convert from base 27 directly into hex, right? I haven't done it, but this is one way you can do it. Okay, that's a fantastic discussion. That's fantastic, right? And in fact, you can have a discussion that says, in fact, I have a way in which you can convert from base 27 to any base you want, right? Base 256 even. If you use this procedure, so it's all the same, right? At the end of the day, everything's the same. In fact, in computers, you have a byte that's 256, right? There's 8 bits, 256 patterns. So each byte is basically one character in a 256 byte, in a 256 number system. It is a system of numbers in which there are 256 numbers. In decimal, you only have 10 numbers, right? 10 digits, 0 through 9, right? Hexadecimal, you have 16 digits, 0 through F, right? Octal, 8 digits, 0 through 7. Base 27, 27 digits, space through Z. In byte-wise binary, you have 256 digits, right? The first digit is all zeros. The second digit is all zeros except 1, right? So each bit pattern is a different digit. And you can think about it that way. So it doesn't really matter if it's 256 bits, or you can even have a computer that technically has, some huge infinite number of bits. I don't know if actually infinite will, maybe you can come up with a mathematical, framework for that to work. But you can have any number of bits, right? You can have 1,000 bits even, right? That could be one number that is described in 1,000 bits. Think about it, right? If you look at a number that we write today, 9 or 8 like that, you look at that with a microscope, right? You look at 8 on a newspaper sheet with a microscope, you can actually see it's not one number, it's lots of numbers. Each number, you look at it, you see a ink or no ink or no ink, right? You see these individual shapes, 0, 1, 0, 1. You could look at it with a microscope, you can actually see the 8 being made up with lots and lots of zeros and ones. Yes? Okay, so just like that, a byte is got 256 patterns. 256 patterns in it. In our case, the pattern is 2-dimensional, right? Because the number can go up and down and things like that. But you can think about creatures, beings that live in 1-dimensional space, right? So they can't go up; they can only go this way. How will they write the numbers? They can't go this way, so they can't write 4 like that. They got to write this way, so they can say my 1 is this, my 2 is going to be that and that. So they go only horizontally. That's your byte. Yeah, a byte is basically a 1-dimensional number. A regular number is a 2-dimensional number. Yeah, does that perspective help you in understanding better? And think about it more, or maybe you can noodle this more and explore that more, that perspective more in the forums. Okay, if it's interesting, right? And if it's actually a really, really interesting perspective and you develop that, you can just cross-link that to Stack Overflow and maybe it'll just get picked up. Maybe you write something that's interesting that someone could run as a column and say, hey, can we syndicate that? Not syndicate that, can we pick that up and run it as a column? Or Wired magazine as an interesting perspective on what a byte is, right? From a student at Foothill College. It's really cool, isn't it? Yeah.
So I converted the special number that I created with my name,
Sean,
to binary.
SCAN?
Yeah, SCAN to binary, or to decimal, and then to binary, and then to what was the other one? Hex.
Hex? Yeah, you did that?
Yeah, hex, and then it was easy to convert from binary to hex, right? Because it's like made up, like each one is like made up. Is there an easy way to convert from binary to octal?
Yes, there
right?
is an easy way.
Is it just using half of it, or I'm not really sure.
No. See, a hex is 4 bits, isn't it?
Right.
How many bits is octal? What's the
Octal's
maximum
8.
number? 8? And
Yeah.
what is that?
Is 2
How many
times.
bits? How many bits?
Oh, how many bits in hex or no? In
How many
in
bits?
octal?
How many bits do you need to represent the maximum number in octal?
In octal, it would be uh,
What is it? What is the biggest octal number?
the biggest octal number would be 8.
Actually, it's
I know.
7. Right, I shouldn't say number.
7?
Yeah, 7 is the biggest octal
7.
digit. I
Okay.
should have said digit.
Okay.
Right.
All right.
Biggest
Yeah.
octal 7. 7 in binary is 1, 1, 1.
Okay.
Okay? 1 plus 2 plus 4. 4 plus 2 plus 1. 7.
Right.
Right. So 1, 1, 1 is 3 bits, or 2 to the 3. Octal is 2 to the 3. 2 to the 3 is 8. So 3 bits for octal. Okay, so that's enough of a hint for you, because anything more, I'll be eating your lunch. So you feel free to ask more questions in the forums if you want, but this is an interesting hint for you. So if you want an easy way to convert from binary to octal, okay, so that's a very useful and easy hint. Maybe not just you, but if you could discuss this in the forums and come up with a way. Yeah.
Okay. Thank you.
Right, and come up with different ways of converting from one to another. And talk about the pros and cons and say this is easy to program, this is easy to things like that. Okay, it'll be fun. I can assure you. Right, you guys are going to have a great time, and many of you will also, I'm pretty sure, continue on to do CS2B with me and 2C with me, especially if what you're going to do here is going to count for credit, right? And you'll be able to be fantastic programs, right? Making lots of really cool things for yourself and others. Is that all right? Any other questions? Justin, you've been very quiet. No? Ryan, Zach, yeah. All right, next, yeah, I'll try and change the meeting so that you can just join automatically. So some of you who just came late, you don't have to be waiting in the waiting room. Is that okay? There's a couple of chat messages. By the way, I don't see chat, okay? Chat, I just minimize the chat window because I can't see. I'm on my MacBook Pro. Yeah, I don't waste my real estate on the screen to see the chat. So you have to speak. Okay, is that okay? Are you guys happy? Are you guys planning to come back on Thursday?
Yeah.
Yeah. Yep. Okay. Great. I always ask that at the end of the first class because you're never sure because this class is different. All said and done, this class is very different from all the other classes you've done. So I recognize it's not everybody's cup of tea.
This is my first class ever, so my expectation for my other classes are probably.
Well, yeah, I just want this class to be a fun class for everybody, and I have a good feeling about this class. And hopefully, yeah, we'll all have a great deal of fun. We'll all have a great deal of fun, and hopefully, I will be able to guide some of you after CS2C to do something really, really good, right? So that's something that you can be totally proud of. But just keep on this track. You've chosen a good track. You've chosen a really good track. And the reason I say that is because people who do Java and Python, they're usually more short-sighted into saying, I want to learn this because I want to get, Java certification or Python certification or cloud certification and go and get a job and so on and so forth. But on the whole, not always, on the whole, people who want to learn C++ are not after short-term goals. They just want to learn the principles, concepts. They want to learn the nuts and bolts, right? They're not after immediate low-hanging fruit. There are low-hanging fruit, but they want to learn how can I do this so that I can do some video games, which really require C++, right? And they have, and so they are after the concepts, which means that you actually have a great time in class. All right. Thank you all so much. Yeah.
Thank you,
Professor. Before you go, a more logistics question. I think I may have registered for the wrong class. I'm a second semester CS student. I'm hopping between different colleges just because that's the available.
Oh, I say you want to do CS2B.
Yes. So if there are open seats, otherwise
All right, Zane. Zach. Okay,
Yes,
there are open seats in CS2B, but the same rules apply to everyone. All right. If you're a second year CS2, you won't have any problems. I can assure you. Complete all of the blue classes by the end of this week. Right. Actually, technically, Zach, you can get an ad code until week 2, right? Ad codes are possible to be issued until the end of week 2. That's next Friday, but don't wait until then. I suspect that you should just be able to breeze through all of this blue classes, get it done as soon as possible, get the ad code, and start attending CS2B starting the very next meeting, which will be on Monday. Okay, next Monday, not
The following Monday. Gotcha.
okay. So finish all the blue quests as soon as possible. Then you get a guaranteed ad code for 2B.
All right. Sounds good.
And you get credit. You get credits in 2B too.
That'll be really nice.
All right, cool.
All right.
All right, I'll see you guys later. Okay. Hey, Dwayne. I'll make sure that if you step out of the meeting, you can come back. Okay, you don't have to sit in the waiting room. Okay.
Okay.
All right. And yeah, jazz up all your classmates. Make sure everybody's coming to class. Okay. I want to see more of you in class and more action in class. Okay, and more of you talking than me. I'll see you guys on Thursday and have a great rest of the day. Bye.
All right, thank you. Bye.
Bye, Professor.